It's time for a stream. And I gotta say, days like this, I really wish I had 4 screens. So I can have a separate screen for my door, for the chat, for the window of my stream, blah blah blah, and for my code. Maybe even more. Maybe I need 5 screens. Anyway, I have 2 screens and I'm getting started now. I always have to click around here. Today I'm going to make a stereo widening plugin from scratch. But before doing that, I wanna showcase what I wanna achieve, because I found a new technique that I wanted to make transform into a plugin, and it can be heard in this track. So this track has a lot of fancy stereo width, and I think it sounds especially beautiful on headphones, because the technique that I'm going to transform into a plugin has some issues on speakers, but on headphones they just sound so perfect that I just want to make this a plugin. So let's listen to this track without and with this multiband split. So what this multiband split contains, I mean, it sounds cool, right? So what it contains is 2 bands, and in each band it has a stereo split, and in each stereo split it it has an instance of diopter with a bunch of filters and some settings. Yeah, and that's why it is stereo, because one of them is on the left and the other one on the right, and that makes it sound very fancy. And I basically did that on all of these tracks, and that's why they have such a unique kind of sound positioning. It's like every sound is very close to the ear, but yet they all have their own space in the mix, and that's something that I always wanted to achieve. And only yesterday, when I made this beat, I finally realized how I want to achieve this mostly. So now I have made a little demo project so that I have something a little bit easier to work with when working on this plugin. So I already figured out how I want to make a distance parameter, and in my plugin there will also be a mono button for checking the mono compatibility, because you do lose a lot of energy when you're using this technique. So it really is something that you cannot use on every track if you want to make mono compatible club mixes, but just like, I don't know, I personally make music just for myself and for my friends, and we all have stereo systems, so I don't care. Yeah, this one has no multiband split, but just a stereo split. And in each of these lanes, left and right, there is an instance of an all-haas experiment, which is a plugin that I made today just for testing, and has the parameters, number of filters, frequency and feedback. So this is going to be used in the plugin that I'm making now. And what is this for? Oh yeah, I use this for the mono switch. And then maybe I will also make a visualizer so that you can look at the stereo spread while it happens. But maybe not. But that's just, you know, I laid this out to make a little bit of a plan. So this is the plan. Now let's get to work. Here we already have the code of the all-pass filters that I'm going to use, and now I will make a new project. Okay, new plugin project. For now, I will just make a normal Juice plugin project, because that's pretty cool, because then I can later tell people to watch this stream if they want to find out how to make a plugin from scratch with Juice, which is something that I'm sometimes asked. But also because in my new plugin template I haven't figured out all of the graphic things yet that I want to figure out. So I will do that off stream later. So plugin project, and I will call this plugin all-haas, because it's a mixture between an all-pass and a haas effect. But I have to figure out how I want to write this before I can go on. Will I write this with a space, or without a space, or with a line, or with all caps, all-haas? Or does that look a little bit too bold? Anyone opinions on that, by the way? What? I haven't jumped into live stream. Now I have since Spectrum Analyzer come on. What Spectrum Analyzer? I have to check out what this is. I'm sorry, I will not be too distracted by this. But why do I not know about this Spectrum Analyzer? Is it Spectrum Analyzer for Fuba or what? I already like the default one. Okay, how should I call this now? All-haas with all caps in the all, or not? In which case with a space or not? What would look best? Or like it is just one word, but then it's not obvious enough that it's a wordplay. I think I like this one. Okay. All-haas. The more I look at it, the worse it becomes. I should stop looking at it now. I don't know. I think I should add Juice DSP in case that I want to add my own multiband split, because the Juice DSP stuff is better for multiband splits than what I write as multiband splits. And everything else I can keep the way it is. So now I have to define a folder. I will just take this folder. Yeah. Okay. So before we can get started, one of the most important things when working with a default Juice project is that you set the copy step to enabled on both of the build types, so that the VST file is always copied. And important for the release, especially setting the runtime library to static, so that people who don't have the latest C++ distributables installed right now do not have to use an installer to use the plugin. And yeah, it's pretty unlikely that someone doesn't have them yet, with all the plugins that are always being bought, but might happen. Sometimes it happens and the people are confused. Let's see if we have to make any other adjustments before getting started. I am Rugala, and what's this? VST3 AU is currently not supported, but will maybe if someone likes this, and will convert the code once I make it open source. And what is this? It is an not a MIDI effect. Will it have MIDI input? No, I don't think so. None of this. Plugin name all-haas. Plugin description uses all-pass filters to widen signal. Plugin manufacturer. What was that again? Cannot be blank. Yeah, then I will not keep it blank. Manufacturer code. I always forget which one that was. I guess I will solve that later at the moment. This is just some random stuff. Plugin channel configurations, I have to do that in the plugin itself. It's a stereo effect. This is a bit unusual for what I usually do. So this is an effect, it is an FX. And do we have here something that's specifically for stereo stuff? Yeah, we have, okay. That's nice. In Cubase it would be at tools, but stereo is much more descriptive for what it does. This does not have stereo effect and stereo? No, surround is there but not stereo. Okay. Okay, I think that's good enough. So now we have plugin processor, editor, and I will have to add something for the actual effects. Let's see. We want to have files for the all-pass filters. And we want to have files for the actual effect. So this will be the all-haas section. All-haas and all-pass. And we want to have files for the parameter layout thingy. Great. I think that's all I can think of for now. Then let's build this. What? Am I modifying the gain of the side channel? No. No, it's just all pass filters, no gaining. But it would make sense to add a little bit of a side gain parameter in the plugin, maybe. I don't know. Let's find out. Shared code, all-haas, source. Okay, so the first thing now I'm going to do is turn off the GUI so that I can design parameters without having to make GUI stuff. That's always very useful, a very useful first thing to do in a Juice project. A little bit of cleanup here and there so that it's just not so much bloat. It's also very useful. Then here, process block. We will not use the MIDI messages, so we can put them away already. I like to keep this out of the main scope because these variables are not being used anymore after this part. And this is completely useless here. So every process block call always starts like this. If num samples is 0, then return. Because in Cubase, when num samples is 0, then that means there is silence on the track. And I don't like these spaces. Okay, here's the channel layout. This is going to be a little bit interesting. If it's a MIDI effect, but it's not, else this. So let's put this away. Boom. Now, let's actually make a variable and call it stereo. That makes it a little bit easier. So if... Aha, okay. Main out. So this will make it more descriptive. If main out is not stereo. Okay, actually, return main out is stereo. Yeah, that just has to be the case, and else it's wrong. Yeah, I guess. Do we have to consider input channels? Yeah, maybe we do, I don't know. Okay, return main in is the same as main out, and main out is stereo. Everything else does not matter. Okay, much more readable. No spaces, please. So this now just says I want only stereo tracks. This plugin cannot be loaded on mono tracks. Again, a little bit of cleanup for the things we don't need. Because otherwise I will get warnings for that all the time, and that's just annoying me. Okay. Okay, good. Let's run this, just because you have to run things to make sure everything works. What? Oh. Okay, we will still need these things. That's okay. So everything works. That's great. Okay, I guess I will start by just copying the all-pass filters so that we already have everything in the project that we need. So this idea, I actually had it yesterday evening when I was making that beat, and just today I got all of these all-pass filters. I say got because I couldn't figure them out myself, and I got some help for figuring them out. So I'm very thankful for that. Otherwise I couldn't be here now. That was pretty cool. Okay, now I have a header with all-pass filters. I will do the header CPP file thing later, because that, at the beginning it's just in the way when you're just getting started writing some code. Include array. I know we need that. So here we have different kinds of all-pass filters. First of all, let me talk a little bit about the implementations in general. We have an all-pass transpose direct form 1, direct form 2, and the other ones are not direct forms. Second order bcut and second order bcut with bandwidth. And these two classes here are basically just the direct form 2 thing in stereo, and then the stereo thing with slope. So I added some comments to describe the disadvantages of each approach. And the direct form 1 thing, that's basically the simplest. Oh, there is still something missing here. Hey, what? Why? Oh, okay. CMA, thanks, GitHub Copilot. Okay, so the all-pass transpose direct form 1 is the simplest kind of. Oh shit, still something missing. Okay, whatever. Oh no, maybe I need pi in other places as well. I actually have to add a different file before I can go on. So new header file, simply for different math equations that are just generally needed and stuff like that. Okay, I'll just put all of the mathy stuff here. Will I work with double or with float? Because I was told there will be numeric instability. I guess I will play it safe and work with double with filters and all that. Now I want to call it tau, thanks. Okay. Math. Okay. Okay, so now finally, the all-pass transposed direct form 1 is an all-pass filter that is extremely easy to write. As you can see, it only has two variables. That's the whole state it has. And the processing function looks easy, and updating the parameter also looks easy, which is pretty cool. That's why it performs very fast. But it has no bandwidth parameter, and it has numeric instability due to all of the optimizations that have been done here by the DSP engineers who came up with it, and modulation issues. I don't know why. That's just what I've been told. Actually, the thing with the modulation issues. So what we are going to do here is we will try to make the numeric instability a little bit less prominent by just converting everything to double instead. Later, when I take this library that I'm making now a little more seriously, I will actually template this so that it's not always just double or float, but whatever you want. So now this class works again. I guess I didn't forget anything. Oh, I did. Okay. Oops. So now finally, now everything works. Yeah. So this is the layout that I have for all of my all-haas classes. It is just always a constructor that gives the variables reasonable default values, and there is a copy from method because when a parameter value is changed, I only change the values for the first object, like in the normal way with this formula, and for all the other objects I just copy the relevant coefficients so that it's faster. So all of these classes will have a copy from function that copies from another object of the same type. In this case, just G. Now update parameters. This is something that you will see more often with all-pass filters, that there is something with 10 of pi times frequency divided by sample rate, and then minus 1 divided by plus 1. This is a reoccurring pattern in all-pass filters. I don't know why, but this is just something that will always pop up. And yeah, I cannot say a lot about the processing function because all-pass filters are just weird. I guess it just works. Great. So now the transpose direct from 2, the one that we are going to work with as well, because it has a good performance and the numeric instability so far hasn't been a problem. So I think that's pretty cool. And I don't think that people will modulate the plugin a lot anyway, because stereo widening, you know, that's something that you set to a specific value and then it sits there because you want to place a sound. The sound is not moving so much. And there might be some exceptions, but all in all, that would be the thing. So I will translate this to double now. And meanwhile, say a little bit about it. So as you can see, there are more coefficients than before. AA, A and BB, and Z. Yeah. So the copy from method also looks a little bit more complicated. The Z ones are not being used because they have something to do with the input signal. So they are like the state of, how can I say it? They are a little bit more about past signals that went through this processing method in this fancy way. So they have nothing to do with the coefficients themselves. This is just about copying coefficients. Okay. Update parameters. So this method looks like this. It's, as you can see, it looks quite similar, but has a bit more complexity in it. So this happens once when frequency or Q is changed, and then it just gets copied for the other instances. Now, second order B-cut. Is this the right pronunciation? B-cut, or is it B-quat? I have no idea. So this one looks a little bit more complex because it has more variables down here, but it's actually a little bit easier to understand because it's not an optimized thing, which means it has a worse performance. but better readability. And yeah, that's why I also wrote it down, because I like sometimes getting an overview. So here you can see the thing again with pi hertz sample rate and da 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 da. As I said before, this is reoccurring. And one interesting thing about all-pass filters coefficients is that B1 is A1 and B2 is A0. So there is some sort of symmetry going on here. I would really love to look at that in the unit circle, so that I can actually learn why these values are chosen. But you can already see it here that there is something symmetric going on, which is kind of satisfying. So this has typical IIR filter structure where you're just processing a bunch of added and subtracted values and then make sure that the delay works. Okay. Did I forget any double-ish things? Yep, I did. These are always so sneaky. Okay. And this is the second order B-cut width bandwidth, so the same as the one above, but with a bandwidth parameter, which means that this looks the same, this looks the same, and this looks mostly the same, but slightly different. And the code style is not very consistent because K is written in a capital letter, while most variables are not. That's just because I was working on this so fast earlier that I just didn't care a lot for style. Okay, but I will do that later. Also, you can optimize some of that away, which I didn't do yet, like saying, oops, no, that has to come after this. Like putting all of these together. I will not do that now, but just it's a little info. That's something that you can do. And now it's getting interesting. Now there are the all-pass filters that are actually extending the functionality of all-pass filtering in general. Like here, the very basic thing, just to have a stereo filter, which means an array of 2 filters. And there the copy from method looks like this. It just copies from both filters from a different stereo filter, or update parameters, update the first filter and then copy from the first filter to the second filter. Processing also looks easier now. Now new channel parameter here, of course. And all-pass slope, which means that we have an array of all passes. And there is a number missing here. Okay, yeah, good. So let's go on. New header file, axioms. This is a concept that I have not used in any of my projects yet, but I came up with that recently. I want to have a header file from now on, always, that is just about axioms. So just assumptions that are made at the beginning of the project. So even more basic than that pi is this. And one of these axioms could be that num all-pass filters is 128. The maximum number, that is. That's a problem that I had in the past, that when I wanted to share an information with the place where I make parameters and the place where I actually write the DSP code. And I couldn't do that consistently, and it always led to errors. And now that I have this axiom place, I'm actually able to do that, which is cool. So I guess, I mean, I haven't tested that a lot yet, but I suppose it's going to be cool. Updating parameters, update the first parameter and copy to the others. Okay, and the processing function here, because it's processing a lot of filters in series, looks a little bit different. Just saying, okay, output is X, and then looping through all the filters, not all of them actually, not from 0 to num all-pass filters, but to the num filters parameter, so that it is actually parameterized. And then always processing with that all-pass. This is a stereo all-pass. And then at the end returning. And this is the all-pass slope. And now I can get started finally, yay! Or can I? Because I still have to make the parameter layout. But okay, let's just have a little bit of Erfolgserlebnis in German by, wait, let's make this a struct. Just want everything to be public. By actually putting an all-pass filter into the processor to say, okay, I already made something. So now include all-pass. But I just thought about something. Oh no, I have to rewrite some of this a little bit, because in my demo project, of course, it made sense to have an all-pass stereo struct and then having the all-pass slope one owning an all-pass stereo object, but I just remembered that I want to give different parameters to the left and the right channel. So I have to actually put it the other way around. Actually ditch this whole concept of all-pass stereo and instead letting the all-pass slope directly own the transposed direct form 2 one. Okay. Or maybe I just call this one slope stereo and make a new one that is slope mono. Yeah, then I don't have to delete this. That's better. So this is going to be the slope mono one. And it has not this class, but the direct form 2 one. Because it's the best. Now something changes here about how I have to handle this, of course. Let's see. Update the first parameter, then copy to the others from the first. Yeah, that sounds reasonable, that we can keep it like that. And now here, this is, why does it not like this one? Oh, because it's not channelish anymore. Great. Okay, that apart from that, it's still the same. I guess we can keep it like that. So now finally, include array. Here we make our own custom stereo thing. All pass slope, all passes, or all pass filters. Yeah, sounds better. Okay, so there was no preparing, so we can ignore prepare to play, which is nice. Actually, not quite. Or can we? Yeah, we can. Sorry. So now here in process block, at some point there will be the moment where I say loop through the channels, which are exactly 2 because we defined it in the stereo layout. What? No channels yet? Oh, okay. Loop through the channels and then have all pass filters of this channel be the all pass filter and use that all pass filter to process x with num filters. What is that? There is one argument too much. I forgot about that. Of course, we don't need this argument. Okay. And it will return an x. So this is sample based. Could make it block based for better readability, but for now I will just keep it like this. And when that's the case, then there will also have to be all samples and the samples of this particular channel. So we can put here samples of S, and the all-pass also returns into samples of S. Now we just need the num filters parameter. For now we could actually go on and say this axiom num all-pass filters. Nice. The axiom header really does something nice. By the way, everyone, what's your favorite tea? I have peppermint tea here. That's one of my favorites. Let me know in the chat what you like most. While I'm thinking about what to do next. I think next up I will have to do parameters. Like always, I will not write them from scratch, because that's a lot. Even though I did that earlier this day, for fun. That is. Okay. I will just have to follow through the things that I did earlier this day, because I will have done them for a specific reason, I guess. So let's go ahead and copy this to my other project's math place. It's not all math, by the way. It's a bit inconsistent. There's also string stuff here. I don't know. I just didn't find a better place for this type of miscellaneous thingy. And this will now have to be templated. So node to frequency hertz, MIDI nodes. That is because that's useful for making parameters that feel good in the frequency range. So making some static casts for whatever this template's type will be. I guess it will be double, but there can sometimes be reasons to use something else instead. Yeah, so I think in this plugin I will refrain from adding Xen harmonic features, even though we could use this parameter if we wanted to. But I don't want to make it too complex, and I think it will not be about exact pitches anyway. So let's just not do that. This doesn't need any more help. Okay. So next up we need ranges. This is the range part of my parameter stuff. Okay, I think we can this time actually put that into the parameter namespace. Usually I like to keep that separated, but yeah, let's just keep it simple. So what was normalizable range part of again? In order to find that out, I go to oh, I can already keep that open for later. Okay, juice normalizable range. Shit, now you saw that I like to procrastinate on Facebook. I'm such a lazy boy. What is this? Brave search. I really like to avoid Google, but it's sometimes just not possible when Brave search gives me such bad results. Okay, so this is part of Juice Core. Okay. choose core. Great. So now using range as this range, it's always float anyway, so I can do that. And now I have all of my favorite ranges in this project, so that when I make parameter ranges, I don't have to think about that a lot. With my make range namespace. You can find that in any of my PZ. This is not a money stream. It's not monetized. I was asked if I wanted to monetize it, but I remembered all the times that I was in a stream and then suddenly there was an ad at a really exciting moment and I clicked off. So I decided that it kind of sucks. Okay, you find my make range namespace in all of my projects, so I don't have to show you what it is. Now it's just for making parameter ranges that feel good. Okay, next thing is value to string methods. Yeah, string to value, I can solve that later, but value to string is really important. So here is a method that converts, so value to string methods are methods that convert floats to strings. And here this one converts Hertz values into strings that look like Hertz values. What's still missing? Nothing. Okay. So this is needed for pitch parameters, but also the note value to string, because it can be displayed in pitch, but also in Hertz at the same time. So that's the reason why I had the pitch class to string method earlier. Now this is a little bit of an illogical way of figuring out how to make a plugin. Usually you would not have such a streamlined workflow. This is mostly because I did this earlier this day, but still can give people a good overview over what you actually have to do in a plugin project in general. So this is the value to string for nodes. You can see it here a little bit. Did I even use this? I did not. Anyway, pitch. Okay. And this is the one that I actually use. So this just says write the note value and then write the Hertz value. Okay, great. So this was a lot of a run up for what's coming. Now the actual parameter stuff begins. And the method for creating parameters. All of this is very useful. I will copy it. And then finally something a little bit more unique to this project happens, which is deciding the PIDs. So first of all, I want to have a distance parameter. And this distance parameter will mostly just modulate the number of filters, but maybe in a more fancy way than just turning them on and off, because that has discontinuities. And then there will be the cutoff frequency for the left channel. Will I write left cutoff, or will I write cutoff left? Let me think of it. In which sequence do I want the parameters to pop up on top of each other? Oh, I think I want to actually have them sorted like this. Cutoff left, then cutoff right, because the sequence in which I write this down will also be the sequence that it's like shown in Bitwig in the view that has no GUI. When I later make a GUI, I can arrange things the way I want anyway, but it's still important to nail this part. So there will be a cutoff for the left, cutoff frequency for the left channel and for the right channel, and there will be a feedback parameter for the left and for the right channel. At some point there will be a mono button just for checking in mono. Do I call it mono check or just mono? I don't know. Actually, Mono. Do these kind of things have a special name in other plugins? I don't know. Okay, I just call it mono for now, the mono switch. So I don't have to nail the parameter layout yet. I can still add parameters later as long as I don't give this plugin to people who make presets. So this doesn't have to be perfect now, but this is the most important stuff. Yeah. Now the string methods. Okay, let's start from scratch. Distance, cut off left, right, feedback, thanks. That's exactly what I wanted to have. Okay, the toID method just transforms the string into an ID, removing spaces and all lowercase thingy. Now this requires me to... Wait, what? Why does it not know that? Alright, because it is in Use Audio Processors. Man, I'm waiting for the moment where GitHub Copilot just listens to your voice. Imagine you can just sit there like, hey, you still have to include audio processors, and suddenly boom. That would be so cool. GitHub Copilot is one of the only AIs that actually works pretty well. So here is my make param method that automatically makes params with a little bit less coding involved. You just have to give it the ID, it will automatically figure out the ID and string, and then you can give it a range, which will be a 0 to 1 range by default, and the default value is by default 0.5. And value to string and string to value, which also have default values if you don't want to set them, which is pretty nice. Because then you can much easier get started. And now it's finally time to actually make the parameter layout. Oopsie. Void make parameter layout. Okay. For this task, I will again copy something from somewhere else, which is all this, basically. Okay, so what's going on here? This is not the same namespace anymore. First of all, I will make this work, and then I will change it so that it fits to this project. So here it can already be seen that my make parameter method looks pretty clean and short, especially when you can put all of these namespace thingies away. What? Oh, my axiom is not here. Then how is it even an axiom if it's not here? Thanks. Sometimes I think it does listen to me. Or I just remembered that I was working on this line, I don't know. Okay. And of course these don't fit because I changed the PIDs. But anyway, I will keep these for now because some of these already had pretty nice ranges. So here are ranges and stuff like that. The pitch range, blah blah blah. I can keep the pitch range, of course. But now going on to the processor, because we need audio processor value tree state. Choose. Oh, thanks. Okay. Maybe it really does listen already. I don't know. This null pointer parameters. Does it have to be capital letters or not? I have no idea. Create parameters. Now create parameters doesn't work, but if we include the parameter header, then there is the chance of just saying param create parameter layout. Or not? I apparently called it a different way, or it's just because I can't type. Yeah, that's it. Param Come on, let's go. Make parameter layout. Okay, I think create sounds nicer. Let's go. Come on. I want to see it working. Thanks. Okay, now next up, we have to make sure that parameters actually are serialized, loaded and saved properly. I don't know, the most tutorials for some reason like not really mention that. I don't know why. I think it's pretty important, especially in the beginning, so that you don't have to recover your settings every time you test something. And it's pretty easy as well. You just always have to copy the same code over and over again into new projects, which is this chunk and this chunk. Boom, now parameters are saved and loaded properly. Cool. Why does it still not like this? Hello? What's the problem? It wants to have the parameter layout, yeah. And I give it the parameter layout. Or maybe no caps. No, that would be a different type of error. Okay, maybe I didn't call it APVTS, but AVPTS? APVTS. I did call it like that. Okay. Why does it not like that? Okay, I don't know. Does anyone have an idea maybe in the chat? Hey, my headphone's lagging. Wait up. Test. Ah, my old adapter is not really working anymore. That's very unfortunate when making a stereo widening plug-in for headphones, but come on. Hello, please just work now. Please just do your thing. You can break completely some other day. Come on. Okay, that sounds good. Okay, this doesn't work because, alright, because I said that this is void, but of course it does not return void, but obviously it returns choose on your processor value tree set parameter layout. I think the juice framework gives sometimes things too long names. I don't like that. Okay, now that we have the parameter layout thing working, we actually have to make sure that adding parameters works. So starting with the distance parameter, layout add make param PID distance. Now you have to make a little bit of a decision. Do I want to measure the distance in filters and have some people confused over things like, hey, what does 31 or something mean? How's that distance? Is this in meters or what? What curly braces? What? Oh, you were answering my question. No, it was the return type missing. So do I want people to define a distance in percent, like from 0 to 1, 0 to 100 thingy, or do I want them to actually know how many filters they currently use? I think I will actually use filters for now. Let's just keep it technical for now. And of course we don't start at 0 but at 1. There always has to be at least one filter. So the default value is, let's say, what's nice default value, 24 filters, whatever. Can still tweak that later. And then we need a val to string, and that will just be the what will it be? I decide later. Now next parameter, add. The next parameter that we have here is cut off left which uses the pitch range and the default pitch. Oh, actually I think there have to be different default pitches for each side, so that the moment you open the plugin it's already very interesting. So let's ditch the concept of a default pitch and instead just hard code one into here, like 48. And then val to string for pitch. And I don't care about string to val yet, because that would mean that I have to actually add my formula parser. And yeah, that's just a bit off topic now, adding a formula parser and all that. So this is going to be 62. And now feedback. The feedback parameter is also in hertz or in pitch, so it also kind of uses a similar way of creating the range. But instead of ranging from 12 to 127, or I could actually go even deeper with that. I don't know if that makes sense. Maybe. So instead of that, I let it start at 1 and go only up to 12. Maybe that was already too much. I think, yeah, when I tested that earlier, I think it already went too far. So we only want really low values here. Range Q, default Q is 1, so this corresponds to no Q factor at all, just like a normal all-pass filter. And value to string pitch is the same as this one. So maybe I make it a little more straightforward by actually not creating the same object again. Okay, now same for right. Okay, for here I will keep the default values, because usually the default value of 1 is the most subtle one, and I guess people will always like that a lot as a starting point. Now the mono button, it can make things mono, but that's not what people want from the beginning, so it's turned off by default. Is this the right way? PID, then range, okay, toggle. Default value 0, yeah, that's the right way, okay. Great. I will care for the val to string thing later. Now we have all of the parameters, and now I will make an array of parameters so that I don't have to keep on using the APVTS for that. Or actually I will make a vector. Oh, wait, slightly better performance with array probably. Okay, then choose audio ranged audio parameter pointer param num params. The namespace is called param. So an array of ranged audio parameter pointers. So typically having it as vector is nicer, because then you can use a for loop, not this one, but some for loop to fill the vector. Using an array is not so nice, but I will just do that now because I want this to perform well. Because in an array you have to actually manually write out the constructor, which kind of sucks. Oh, actually it doesn't suck. It only sucks when there is no GitHub Copilot. Okay. But it still sucks a little bit because I have to write the first thing from scratch. So this is param to ID PID oops, again param PID distance commata, and now the other ones. Wait, what? There is no width. Okay, thanks. That has worked out correctly. Oopsie. Okay, this should have worked. Now let's try actually building this every once in a while to find out if we forgot about something. Like here there seems to be, I forgot about a bunch of double and float Compatibility thingies. Like what? Oh. Man, I just wanted to drink something. Give me a break. Okay, I'm not using the stereo thing anymore anyway, but still I want to have it right. Okay, and this? That's the same problem. And this? Also the same problem. What's going on with all this? Convert from const char to int? Oh, what? No, it should convert to string. Okay, I don't get it now. It's weird, but I don't need to worry about that now. I just need to worry about the actual errors. Or is this an actual error? Oh. Yeah, okay. What? Oh, it doesn't know what string is. That's the case. Okay. It's part of Juice Core. Hello? Yeah. So now please build. Finally, the plugin builds. It has its all-pass filter. It's not connected to parameters yet, but you can see the parameters do things. The distance parameter still doesn't look very descriptive, like what is distance? It is some value between 1 and 128. Sounds pretty random, but that's what it technically is. Cut off left in pitch and in hertz. And feedback also in pitch. This one looks a little bit weird in pitch because it like has this minus value. People will not understand what it means that a feedback parameter is in a pitch. But the hertz value actually makes kind of sense, like from 8 to 12 hertz. That's something that people can maybe imagine a little bit, but maybe I have to come up with new units for these. And the mono switch. Great. Okay. So let's start simple. The mono switch. After all of the processing, there will be the question. Mono param. What is this? Oh, this is terrible. Okay, let's write this from scratch. Params casting the PID of, or actually let's first of all make sure that PID is part of this class so that we don't have to write out the namespace all the time. Okay, so PID of mono dereferencing and then immediately referencing. So this is now a reference to the ranged audio parameter mono. If mono param get value is bigger than 0.5, which means that this is true, then we want to mono the signal. So, oh, actually, we don't need anything fancy. Really, just that? No, that's also a little bit too easy. Okay, we already know that there will always be at least 2 channels because the channel layout has given us this limitation. Okay, samples of 0 of S. Oh wait, mid channel is samples of 0 of S plus 1, not exactly, times 0.5. Okay, mid and is also mid. Okay, let's just write that on in one line. Great. So now we already have one of the parameters functionality done, and it's just about the all-pass filters from now on. Maybe we could start with a number of filters thing. Distance parameter. And now when the parameter is a little bit more complicated than a mono button, I like to also get the range out of this. The range of the distance is get normalizable range. Num filters is distance range converting from 0 to 1, the parameter value. What is this? No, there is no multiplying. Yeah, so this returns a normalized value and then it's denormalized and then it's converted to int. But in between these should also be rounded because converting to int always rounds down, which is not very intuitive. So this makes it a little bit more intuitive. Num filters. Actually, let me check. Where were the parameters? If I use stepped values for this, then it will not be on a different value than the pitches. Do I want that? No, no, I don't. Because this is not so much about the pitch itself. Pitch is just a little bit of a helper tool here. Yeah. Wait, no, wait, that's not the pitch parameter. Oh, I was just confused. Sure, this one needs to be stepped. The other ones, range pitch, they are already lin. So my lin range is just like my stepped range. The only difference is that this one is not stepped, while the stepped one is it just uses the default constructor of normalizable range where you can use set the steps. And the toggle one makes a stepped one that is just between 0 and 1 and can only have these two values because of that. Okay. Now that was a little bit distracting. Next up, I need to have a mechanism here for if parameter values have been changed. And that's usually the reason why I like to have separate headers for the thing that the plugin is actually used for. Because then I can make a nice little struct about that. The all-haas struct. And now I just noticed having all-haas written like this and instead of all caps actually does look cool when the font looks cool. The font of the producer just does not look very cool. So that's why it looks better like this here. I may need to rename the plugin. Okay. All-haas. So this is the processing method, and we will need the sample rate. That's for sure. I don't know yet if we need the block size. Sample rate is definitely needed. Great. So as a default sample rate, I take 1 so that it doesn't crash, but if we don't use prepare, then something extremely weird will happen. That's how I like to handle default values of sample rates. Now I can actually go there and say, okay, the all-pass filter is actually part of this thing. Oh, I need to close some of these things. It's too much. I don't need to have this open or this or this or my axioms. This still a little bit, yeah. Okay. Include all pass filters. Okay. Now I can copy some of this stuff. And now there need to be additional parameters. This will be at the end, and in between there will be the parameters. For example, the number of filters, which is defined by the distance, or which defines the distance. And I always like to write it like this, because then I can have a member variable in here for the parameters, and then say something like, if num filters is not num filters, then it is num filters, and the all pass filters can be updated. All pass update parameters, frequency, Q, fs, and num filters. Now some of these are still missing, obviously, but that's just how it is. Okay, there will be nothing more fancy going on here. This is just the processing method. Another thing I really like about subclassing processing, audio processing into classes like this is that I can tidy up the processing function a lot by just making little functions like actually process filters. Can just go ahead and say, okay, processing filters is a different process than updating parameters, so it has its own little function. For nice code readability and all that. Boom. Okay, nice. Now I can focus more on the actual challenges of this class, which is updating parameters in a good way. What's missing? Oh, okay, num filters needs a default value, so num filters needs a default value that it never has, for example -1, so that the first time this hits, it will immediately update. That's important. Okay, now I think I will have to go into the all-pass filters and update some of the structure that it has, that they have a little bit, because otherwise every time the number of filters changes I have to update the frequencies as well, which kind of makes no sense, I think, because, or does it? Let's see. Oh, it actually makes sense, because I'm only looping 2 num filters, so if an earlier parameter change does not change all of the all passes, then there could be inconsistencies when turning it up again. So it does make sense that changing the numbers of filters updates everything. Okay, good to know. Now we can throw out all paths from here. We don't have to include array because it's included in a lot of these already. Oh, actually, yeah, we do have to because it's a different namespace. Okay, and now all-haas. This will make this look a little bit easier. All-haas. Okay. Prepare to play. Sample rate. Thanks. Now here, all-haas with samples, num filters, num channels, and num samples. Why not? Oh, it is float const and not float. Okay, right. I forgot about that. Now it works. Okay. Now the other parameters. Okay, let's just do it. Frequency left. Oh wait, I called it cutoff. Left. No, it's I first just want to have the parameter. Okay. But not as a pointer. I don't want to work with pointers. Oopsie. My focus leaves me, but that's not a problem. I wanna get to a point where I actually can hear the plugin working, producing sound before I end the stream. I'm on a good pace right now. It will work. Okay, range. Yeah, of course. Wait up. We only need one range because the right one works the same, and I will not change that. So the cutoff range. And now what? Oh, okay. Still have to decide for one. And now the same for the feedback thing. Okay. Now values. Yeah, that's correct. Go on. Cutoff right. Feedback left. Feedback right. Now, obviously, these need to be casted to double, since the filters all work with double. So we could already do that here so that we don't have to do that later. So when methods start to have a lot of input arguments, I like to write it like this. Okay. Yeah. All-haas, double, cutoff left, cutoff right, feedback left, feedback right. Okay, good. Okay, how do I do that now? All of these, whenever they have changed, we'll have to introduce a parameter update. Okay, and that also means they need default values. Best negative default values so that they are impossible to reach. Okay, negative feedback values. Can that be a thing? Maybe it can, but I don't know yet. Okay. Oh, process filters needs to be adjusted. Okay, now it works, right? I just remembered, since this is a double filter, we have to cast things a little bit here. and at the end cast it back to float. Let's do it right from the start. Okay. Now, if cut off left is not cut off left, or cut off right is not cut off right, or feedback left is not feedback right, or feedback right is not feedback right, or num filters is not num filters, then boom, 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 and boom. And then okay, I cannot use this loop anymore because it's different for left and right. That's okay. So the left filter will be updated with the left properties. Okay. And the right one will be updated with the right properties. Yeah, I think that's already the best thing, the best optimization that's possible here, but maybe not. And then the filters are being processed, and that should now be sufficient as a plugin. Right? Can I build this? Oh, I don't have any people viewing my stream anymore, even though now it's getting interesting. Damn. What's this? A value turned out to be negative. From where? Feedback left. Get value. Why can the feedback parameter be negative? That makes no sense. Did I do everything in the right order? Okay. PID, distance. Left, right, mono. That's all. Then creating parameters. Distance, left, right, mono. Correct. Array. Distance, left, right, mono. So they are in the right sequence. So why does this not work? Some breakpoint programming will be the thing now. So the value here is question mark. Okay. Interesting. So it doesn't know its value. And now the value is 1. Okay. Step out. And when the value 1 goes into the convert 0 to 1 function, then oh wait, it's not 1 anymore. Now it's minus some value. Of course, that's not good. Okay, so what was the issue? Range Q from 1 to 8. Or did I set up the array in the wrong way? It's an array of ranged audio parameter pointers of num params, which is 6. And it's defined up here. To ID. Maybe we should set a breakpoint here to check if the parameters were set up correctly. Okay, so params so this looks very much like everything is set up correctly. Default value of 1. It sounds good, except if default values are in normalized values instead of denormalized ones. I actually don't know. Even if they are. Normalized, it should work. That's not the problem. Au. Was geht, Katze? Irgendwann am Stream. Mach grad ein Plugin. Gerade ist keiner da, glaube ich. Hä? Ja, ich weiß, du bist eine Katze. Habe ich verstanden. So. Oh. Okay. I will just keep on talking to the mic even though no one's there, because in case someone watches this later on, I still want everything to be explained that I'm doing. So first of all, I'm fixing something that I should have fixed before. All of these come out here as pitch values. And that's cool. But also, not very cool, because this function here wants it to be a Hertz value. Or maybe only when the parameter actually updates. Yeah, maybe only then. Okay, so if any of the values have changed, then new Hertz values will be calculated. Math of not frequency Hertz, cutoff left, and the same for right, and the same for feedback. Oh wait, not the same for feedback, because I think I will change it for feedback soon to just Hertz anyway. And now, even though I don't know why it currently doesn't work with a feedback parameter, I will just ignore that now and instead try to make just from 1 to 20 range feedback, default feedback, and a normal Hertz parameter, I mean. So I will have a different value to string here, val to string Hertz. So this will be Hertz directly, and the other one will be in pitch, because it's such a small range from 1 to 20 Hertz. It doesn't need to have this logarithmic skewing that a pitch parameter provides. And maybe, I don't know, maybe that already had something to do with the issue, so could be that it is now fixed. And here I will put this value up again. Okay, so we have the feedback parameters, cutoff parameters, and the number of filters as parameters. Yeah, let's not make this too granular here. It's time to run this. Oh, I got a viewer again. So the current problem is that my plugin doesn't work because one of the parameters is not denormalized correctly. If you have an idea why that might be, that would be pretty cool, because I'm just so close to actually building something that can produce a nice sound, and that would mean that I have accomplished something huge for today. But I just can't reach it, because for some reason the value minus 0.1 is ending up in this part of normalizable range, and the chord stack says comes from here as plus 0.31 for some reason, so it just doesn't make sense. And yeah, it's just happening. Oh, this time it's happening in the cutoff left. The last time it happened in feedback left. So this is interesting. It means that there is something more fundamental going wrong here. Weird. Oh wait, I have to get the comp, not a comp filter actually, but a real comp, and comp the hair of my cat. It's very zerzaust. Katze. Meow. So my code can wait for a bit. My cat has, it's a Persian cat. The hair is really, really long. Sometimes it just tries to mess with you. Also, taking a little bit of a break from coding can give you new ideas about the problems. So I'll just do that now. Okay, du willst eigentlich auch mal Hallo sagen am Stream. Soll ich dich mal in die Kamera reinhalten? Nee, du magst das nicht so, ne? Okay. That was a lot of hair. Okay, so I want to find out if the references work here. That's why I set a breakpoint here. And I can see, yeah, we can hover these objects and the references are there, they work. So why would any of this not work? Wait, we can try something else. Maybe some of the state is just broken. We can remove the state handling stuff for now. And just see what would happen if the plugin is started the first time. Come on, let's go. And this also doesn't work. Shit. So it's not the state. I mean, that's cool. I don't like when things are the state. But it would have been cool if we had solved this problem now as well. Then I will take a different approach to this problem. So these are in hertz and the other ones are in pitch. And I commented them out so they don't exist anymore. And that means I can also comment out the rest of everything. And now I will use just static values to see if that performs nicely. Cutoff left is now at 48. Cutoff right is at 62. And feedback left hertz is 1, feedback right hertz is 1. This should be the default setting, I guess. Now this should work and we should be able to listen to stuff. We can just not adjust the parameters yet. There was an unused default slope thingy. Oh yeah, right. Right. So the distance of the range I mean the range of the distance parameter, right? looks a little better. Wait, what? Oh, I'm not using that one. Okay. So now, did I actually think about all of the things? Okay, this is a warning that I always get. That's not the problem. Can I run this? I can still not run this. Why this time? This time is it the distance, but why? Didn't it work before? Okay, no parameters. There are no parameters except for the mono parameter. Maybe, probably also not that one. What? Why does the mono parameter oh, okay, I get it. The mono parameter works because it doesn't denormalize the value. But why do my denormalizing functions not work? That makes no sense. Anyway, it must be a small problem, since it is just one problem for all of the parameters, and it's all the same problem. Okay, now here we're back in Bitwig. And when I here now load all-haas, I see with this font, it also looks quite nice to have it in caps starting. Anyway. No output. Shit. Why? Okay, cool. What could it be? Okay. Okay, I have an idea. I just set a breakpoint. Build. Why would there be no sound? Okay. We got some values here, cutoff left, right, feedback right. Now filters going into all-haas, step into, and here, did anything change? No. So the parameters are not updated, but did they already update before? That's the question. We can look at that. All-pass slope. Yeah, I want to look at one of the all-pass slopes, please. So maybe the first one. And there are 128 all-passes, and the first one of them has a bunch of values for the coefficients, but it didn't save any samples in the past. So the silence is already there at this point. Good. Good to know. But how can it already have lost the sound before? No, that makes no sense. So here there is clearly a dry sample coming in. 0.028, 0.0281, 0.0276. This is all samples. There is no silence. The silence comes from the filter. Okay, just to put this into different lines makes it easier to debug things, which is nice. But we already saw it comes from the filter, so I don't know. So the default values are all impossible values to reach. So in the first moment the plugin is activated, it will definitely trigger this state, because it says if this changed, if this is not the same, or 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 this is not the same, update the values, and then update the filters. And updating a filter means updating the first filter and copying the coefficients into the other filters. That looks reasonable. If my parameters now worked, I could debug this way better. That sucks. So now I have two problems at the same time, and that's really in my way. Let's see what this will do. Where's my mouse? Oh, battery's empty. So it seems like the gods are against me, but against all odds I will now finish this. So there is sound, 0.059 something, blah 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 blah. First all pass, and then boom, Y becomes still a sound. So the first all pass works great. Go on, boom. Second all pass, still sound. Boom, it still works. Oh, the filters work. How come? Wait, why do the filters work? I thought they didn't. So okay, continue next time. So now we are in the next process block. Y is some value. And now the filter works. That can't be. We just measured that that there is silence coming out of the filters. That's weird. Or did we actually measure something else? Hä? Oh, oopsie. What am I doing? So the all pass. I'm currently not using the parameter that I wanted to use. obviously that's a problem, because then it also uses the all-pass filters that did not have their parameters updated yet. Okay, my fault. Okay. Now this should work. Great, it works. It generally works. That's cool. So we have a little bit of a success now. Now we just need to fix the other thing, and it works completely, which is pretty sick. Okay, step by step. A little bit of cleanup, processing filters, blah 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 blah. Let's also give this thing a little bit of its own function. Now that something worked, I feel really encouraged to finish this. So update parameters. Come on. This will get the parameter inputs, the same as these. Great. What I like about having this as a function, like that is separate from the rest of the functionality, is not only that you can then say update parameters here, which has nice readability. Come on, give me the rest of the things. Oh man, is GitHub Copilot broken already? When you're using it too long consecutively, it tends to not like it anymore after a while. So not only this is pretty cool for readability and all that, what I also like even more is that you can turn around these statements. You can turn all of the ors to ands. Oh wait, oopsie. I mean, you can turn all the nots to equals and the ors to ands. Then it will describe the opposite thing. But that's actually even better, because then you can say, is this still the same, and 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 is also this still the same, are all of these still the same, then return. And only if that's not the case, then do all the things, but without having a curly braces here, which is nice. A little bit more readability. So now a return state and else functionality, which just looks very nice in my opinion. Okay. Now one last thing before going on. I wanna make sure that this also reads correctly. That when I come to back later to this, I see that this is in hertz and only this is in pitch, because otherwise I will get confused. I'm pretty sure about that. Yeah. Good. Oh, then I should also update these. Okay. Great. Now this is still has the same functionality, but it looks better. And now about this problem. It didn't like my ranges. Why would it not like my ranges? Which fatal mistake did I do? Let's see. Make range. Range is a normalizable range float. The ranges are defined as I always define, and there is nothing that I changed about that. It cannot be the ranges. Is the fact that it happens on the ranges is just a symptom. It's not the root of the problem, that's for sure. But what is the root? Make param. What does make param do again? Parameter ID, parameter name or string, the range. Hey, show me everything. The default value, is it actually a non-normalized default? Yeah, just like I expected and wanted to. The label, which I don't use, generic parameter, value to string, string to value. Good. Everything looks good so far. Okay, wait. I will do now what I wanted to avoid. I will make, or actually let's just comment this out, because I do want to keep this if possible, but just in case it doesn't work like this, I will make a vector now. I don't know why it wouldn't work like that, but anyway, I want to think about that some other time. Now we can just do this. Hey, why did this happen? Stop. Instead of all that, you know, it could be one of these sneaky C++ memory thingies. Pushing back the parameter with the ID of PIDI. Hey, what? Oh yeah, right, I have to cast the variable. That makes sense. Yeah, not pushback. And place back, since we were reserving. Okay, now the rest of the function should still have the same functionality. Okay, let's try very conservatively. Just take one of these things away, replace it with the actual value, which hopefully now does work. Wait, what? Wait, there was something, hides a class member, blah blah blah. Make a mistake on purpose so that it just stops and tells me just what I want to see here. A class member in all-haas. That's not what I wanted to know, but okay. Where does anything hide a class member? Oh, whoopsie. Now that obviously was wrong. Oh wait. Oh, I don't need an argument here. That's the problem. Of course. Okay. Let's get back to the actual problem. So now again this thing. So it's not because of the array. That's good. I want to keep the array anyway. But why would the normalizable range not work? What is with it? 1 to 128. with a the convert from 0 to 1 function is empty. Okay, yeah, that explains everything. Just have to find out why it's empty, and then it's solved. Alright, so why is it empty? Oh, no wait, value to string pitch is value to string of pitch, and value to string of pitch is returns a value to string. So this thing, something that converts float to constring reference. No wait, something that converts constring reference to float is string to value, and value to string converts float to string. Right. And this function returns such a function. And the make param function makes a parameter with these properties. Maybe there is a naming conflict because of this. Okay, let's add the word funk. Let's get funky. That was not it. I want to change this value, just by the way. Okay. Value to string func, string to val func, default values. They have default values, so there should always be one. Always. For audio audio parameter float. Maybe I made a different mistake. This thing returns ranged audio parameter, and I have ranged audio parameter. Okay, no, that's correct. Because there are different parameter subclasses. Could have been that. Did I use the right keywords? Inline. Yeah, that's right. But maybe this one needs to be static. I don't know. Sometimes these things get weird. Okay, no, I didn't think that would be the thing anyway. I want to know at which point it already thinks that it has no range. So let's just put a breakpoint here. Not no range, but no value to string. But wait. No, it was the range that it doesn't have, right? Not the value to string. Oh, I'm getting confused. I have to fight against that. So what is this? This points to... What the fuck is this shit? Man, that has the worst workflow ever. So there is definitely a function. Cannot tell me a lot about the function, but there is a function. So that works. But then it's returned into a different format in this moment. So is it still the same when it reaches this point? Let's see. Parameters. First parameter. Yeah, it has its function. That's correct. It's not empty. And the range is... Oh no, this thing's empty. Alright, I had to look out for this one. Shit. I have to go back. Shit. First entry pointer of very nice descriptive programming. Contents pointer range, and it's empty. So it really already didn't work from the start. But why? Okay, it's time to investigate this. And for especially, why did it work earlier this day? It must be a really stupid mistake. So here we have definitely some value to string function going on here. And it... Oopsie, I skipped the important bit again. Okay, getting the string from the ID. Distance is the name. Boom. Back with distance. Now getting the ID. Yep, that's cool. Now getting the range. What? String holder utils? I don't know what this is about. Hey, wait. I'm already at the end of the method. I wanted to look at what the range does and how it constructs the audio parameter float. Huh? That makes no sense. Okay, whatever. I just put a breakpoint into audio parameter float. Into the constructor that I'm using. Okay, do we have a value to string function? No, it's empty. Shit, why? Huh? Let's try something. I will now replace all of the linear thingies with my width center method. I mean, maybe that's pretty cool anyway, but I wanted to avoid that. Actually, let's keep the functionality the way it is. So let's try to keep it linear by just saying 127 minus 12, 115. And the center of these is like around 10. And stepped. Yeah, this will also not work. So now I want to make sure that there is always definitely a conversion function, because apparently otherwise it doesn't understand what's going on. So this is not stepped anymore. Shit, now I have to use a hard-coded value again. That sucks. But it's just temporarily. Now, will this fix the thing temporarily? I hope not, actually, because it's kind of dirty. Okay, glad it doesn't work. But still, it's kind of stupid. So it's not because the linear function lacks a value conversion function, I mean, but it's because of a different reason. Then which reason? I wanna make it now. I wanna finish the stream with actually something that works. Can I do it? And if yes, then how? Shit. Okay. Wait. Okay. How can I find out what the problem is? Or maybe I just need to rebuild. Right, I always forget when something just makes absolutely no sense. Then sometimes you just need to rebuild. Okay, it still makes no sense. Okay, let's use the call stack again for that. We are currently in the normalizable range object. That's a pretty useful place to be. We could look at the other values of... Why can I not look at the other values inside of the normalizable range? Does the normalizable range here even exist? Okay. Now we are still in the normalizable range, but now we can actually look at the variables. Start 12 and 127, input value something normalized value. It should work. Makes no sense that it doesn't. Clamp to 0, 1. Symmetric skew false. Function pointer. Okay. Everything looks normal. Okay, I don't know what these three are, but I don't know. So the value was converted successfully to 48 already. It does seem to work. So we return. Wait, why does get value return a denormalized value? That's wrong. That's the problem. It does not do what it was supposed to do. Hosts will expect the value returned to be 0 and 1. Since when does this return the denormalized value already? That makes no sense. Huh? Wait, can this really be true? And in which case, why does it suddenly happen? No, it cannot be true. This is a normalized value. Fuck. But why? Why didn't it show the right value for a short moment of time? So here, a normalized value between 0 and 1. Going into convert. Shit. Okay, stop. Yeah, wait up. I do have at least one viewer. Why did no one tell me? This is convert from 0 to 1. Fucking shit. I knew it was something really stupid, but I wouldn't have expected it to be this stupid. Fuck. I have a good excuse though. I have a bit of a headache today. First of all, I first didn't want to stream in the first place. So the fact that I actually streamed and also finished this despite some headaches is actually pretty cool. Okay, now it's time to actually tweak the plugin. Now it's getting creative again, which is pretty cool. Not time to go to bed yet. So as we have just seen, the range of the feedback parameter starts to kind of highlight on which frequency it currently is, which is not very cool for stereo widening in many cases. So here we can actually now replace the range with my width center method, which we can set to 3. Maybe just choose an even lower default or a lowest value, because I want to know if that works. So now the center will be 3, because that was kind of like the point where it became too obvious, and then you can go up to 20 anyway if you want to, because it can be a creative effect. This should now feel a little bit better than before. Yeah, let's try that. Oh, by the way, can you hear the DAW in the stream? I'm always not sure if that's like transmitted correctly. Yeah, nice. It works, and the feedback parameter now feels quite cool. The cutoff parameters feel cool too. I don't like the labels, they are a little bit more too complex at the moment. But yeah, it doesn't have to be perfect for now. For now I just have this plugin. I can throw it in and it let's find out how good it performs by actually compiling it in release mode. If it performs pretty good, then I'm very happy now. Shit, how long it took me to find this extremely stupid bug. That's crazy. Oh no, I feel sorry for everyone who was with me. Okay, release mode, let's go. By the way, who's still there all the time? I want to know who's the person who's been there all the time already. Let me know in the chat. I've seen you. You are cool. Okay, release build. Oh, that's cool. It barely makes any difference. I cannot see the difference actually. Let's turn up the distance a lot, so maximum number of filters should perform the worst. Yeah, I could see it go up a little bit. Yeah, this plugin performs pretty good. This is now thousands and thousands of filters in series, and it still doesn't reach the top line. Not even these peaks, the performance peaks. That's a good performance. Nice. Okay. Now the next challenges of this plugin development will be making a good UI. I want it to be a cool workflow to balance the left and the right channels parameters with each other, not just knobs that are on top of each other. And then when the GUI is done, I will release it, and yeah, I think that's I think that's enough for now. See you.